Oh, good morning. And I was talking about Thonny, which is an editor and a means of uploading uh, programs in MicroPython up to your ESP32 or whatever processor you're using. And I'm going to just do a little example now. I could do the LED blink, of course, which is what everybody else does. But because we deal with motors a lot on this group anyway, I thought we'd do a PWM one. And whilst you probably can do PWM down at the register level, which my colleague tells me about, there are libraries available, just like there are in Arduino, to do PWM. So here's the program in front of me, which I've written, which does PWM. And so what it's going to do is, first of all, this import thing in the different color, that's importing this module machine, which you nearly always have to do. And the thing called time, the reason I'm using time is because I'm going to use a sleep for 1 second. It's like a delay for 1 second. So I need that, and I need the machine tells me about the pins and things like that. So I need that as well. So those modules I need to import. If I don't, I'll get an error. So for example, I'll forget about machine and just try and run this program. You run it by pressing the green button here, and straight away it says machine isn't defined. Well, that's because I was using it here anyway, but put it back in again. And what it does is it creates a PWM object, which is I've called PWM out machine.pwm, and it's going to be on pin 14, and I'm going to make it quite a low frequency, 50 Hertz, and the width of the pulses is going to change. Now it seems to be a default in MicroPython. I'm not sure at the moment whether there's a way around this. That the depth, if you like, of PWM you get is 1024 levels. That's like the resolution. So you get from 0 to 1023. You don't get any more than that. So this is an infinite loop. It's just going to go around forever. While 1, you can write, you don't need the brackets always, or you can do while true. You do need the colon. And this is a for loop within the infinite loop. And it's just like in C, a for loop for I in range 0. So that means from I going from 0 to 1023. If you're programming in LabVIEW, it would be a graphical thing. Oops, sorry about that. This 50 here is the frequency, is the steps that I'm going to go up. So I'm going to go start at 0, go to 50, 100, 150, so on, and get as close as I can to 1023. If it doesn't get there, it'll go as near as it can. And it's going to print out the steps as I'm going along. And now I'm going to change the duty cycle of the PWM, send it out to pin 14, and I'm going to sleep between the steps of 50. So let's go ahead and run it. And you can see down here, it's called the shell. It's starting at 0, 50, 100, 150, and so on. And in a second, I'll show you the actual waveform that's coming out. And that's really all there is to it. That's PWM in a nutshell. See, it's got as far as 1000. It can't go to 1023 because it would go to 1050 would be the next step, and that's over 1023. So that's near enough for the moment. And that's the first introduction to the programming. Notice though, for the for loop, that there aren't any brackets around it, unlike in C or other languages where you put a curly bracket or something around it to say where the beginning and the end is. Instead, it's got an indent. So if you don't indent these, you'll get an error. So I'll just do that just to show you. I'm going to put the print statement so that it's not indented. That's going to confuse it. So notice that stop is up in the red button up there, or I can do Control C to stop it. And I'll run it again. And again, straight away, it says line 12. Most recent standard line 12, there's an error. It's not quite clear what it is actually, but that's what it is. Maybe I can move it a bit and see what it does if I put it here, and then it'll say there's another different error perhaps. Yes, so now it's saying it's indentation error because it's not aligned with the rest. So I need to put it further in. Oops. And now it should work. So that's one of the small nuances, if you like, of MicroPython. It kind of reminds me a little bit of old-fashioned Fortran. Not quite, but there we had do loops and continue, and you had to indent after that, but you had a continue at the end to tell you where the end was. Here, the end of the for loop just happens naturally at the end of the indent. So if I was to put some more stop. So here's the program again. I'm just zooming in it. And I'm just going to run it, and we'll have a look at the oscilloscope. So that's it running. Now over here is the ESP32, and I've got the scope probe. Well, you probably won't be able to see it, but it's on pin 14, and the ground's there as well. And you can see that the PWM is going through that infinite loop where it's starting at 0 width of pulses, and then the pulses increase slowly until we don't quite get 100% PWM, 100% DC, that is, or the DC component. If you do a Fourier series of PWM, you find that the DC component is the space divided by the period. So as the pulse gets wider, you're getting more DC out to you get the maximum of whatever the power supply of the PWM is, say 5 volts or 3.3 volts, whatever. That's the maximum there. That's it at the minimum. Now, of course, when you're doing this, it's not going to be much good driving a motor with that because it's coming straight out of the pin. So instead, we need an H-bridge, or you can design your own. And the H-bridges, I've got these ones at least. It's quite a big one. This takes about, in theory, it's supposed to be 20 amps. And down here are the pins, the logic pins for channel A and B, so it can power two motors. And it's got A here, B at the other side, and the two power in the middle. So there's 2 output for A, 2 output for B, and the power supply comes in here, which I'm not using it at the moment, obviously. It's not connected. But we need to obviously connect this to the ESP32 before we can drive a motor. And here's our motor here. And that's the next thing we're going to do. So, to drive the DC motor, we require an amplification of the PWM. The voltage and the current output from the ESP32 isn't enough to drive our DC motor. It takes a lot of current. So this is like the equivalent of an amplifier in an analog control system. And I'm just using this one here. There's a huge amount you can pick much cheaper ones. This just happens to be the one I've got a number of these, and they're supposed to be 30 amps, but I doubt if they really are, but they claim to be 30 amps anyway. And this H-bridge sells for that amount in New Zealand, but obviously different in your currency. And there's pictures of it from different angles. Now, if you look at it, you'll see that it's got 2 outputs. I think that's output B, that's output A, and that's the power supply, these 2 here, and this terminal block. And make sure you connect the right way around. This is the low voltage side, and we're only going to use on these pins B. We're not going to use the A output because we've only got 1 motor at the moment. And we're just going to connect the ground. These things called in1 and in2, which I'll come to in a minute. And the EN is actually where the PWM goes. We don't need CT, that's for monitoring the current, and we don't need that, the voltage supply. that voltage supply I think is 12 volts, so you be careful, because if you're feeding 12 volts in, it's not what you might think, 5 volts coming out of there. It seems to supply 12 volts, so you have to watch, don't use that. I don't use it anyway. So the in1 and the in2, although it's not actually specified here on this web page, is the means of whether the motor goes forward or reverse. It's as simple as that. So here, in1 and in2, if you make in1 1 and in1 1 and in2 0, so go in one direction. If you reverse that and make in2 1 and in1 0, it will go in the other direction. And if you put in1 and in2 both to 0, then it will halt the motor. That's quite important, because we've got no feedback around it, and it'll just keeps going basically if you don't do that. So let's have a look at our program, which I've written here. So I've had to, again, written in MicroPython. The modules that we load are machine as usual, and time. We need that just for some delays, otherwise it's a bit fast really. And we need the thing called pin, which I'm going to use in a minute. So they create the PWM object as before. It's from pin 14 and its frequency is 50 Hertz. Then we define in1 from pin 27, and in2 it's coming from pin 26, and that's going to be connected to the H bridge, pins 27 and 26, or whatever pins you want to use, GPIO, general purpose IO, digital outputs, well, in this case, digital. That's actually not an infinite loop, so I'll just delete that because that was from previous program. So let's say however you define forwards as, I'm going to put in1 as the value 0, in2 is value 1. So it's going to go in one direction, whatever it is, and it's just going to go full steam ahead. It's not quite full steam ahead, it's 1000. We know that 1023 is the maximum. And then we're going to sleep for 5 seconds, and then it's going to reverse the other way around. In1 is going to be 1, in2 0, and then it's we're going to put full speed ahead again, 1000, and then sleep again, and then we're going to stop it, and then we're going to reverse it, and then we're going to well, just set it up for reverse rather. We're not actually doing anything because we're not putting any PWM, so we set it up for whatever this is. I think it's reverse, and then I'm just going to put, and it's not an infinite loop, I'm just going to go around from I equals 0 to 1023. So that's I in range 1024 means 0 to 1023. And between each value of I, I'm going to sleep for 100 milliseconds. You notice this MS now. Send out the duty cycle of I, and then when I'm finished all that, I'm going to halt the whole thing, and I'll show you the demo of that now. So I've now connected the ESP32 to our H bridge, and I've connected it to channel B. You can just see that here. I'm not using channel A, so channel B output is to the motor is these two here, and these two are the power supply for 12 volts, or whatever supply I'm using. I've got the motor here, and I've got the oscilloscope connected to the PWM. The connections to the H bridge, there are 4. There's the ground, which is easy to connect, of course. You must have that or it won't work, because there's no common then between the H bridge and the ESP32. Then you've got the 2 wires which are in1 and in2, which I mentioned earlier. That's for forward and reverse or stop. And then you've got finally PWM. The first and the last pin aren't used. One's a V plus and one's a current sensor, so we only use the 4 innermost pins. Here's the PWM, and the PWM is going to pin 14, and I'm monitoring pin 14. So without more ado, let's go to the program again and run it with the green button, and off it goes. So it's got, you see that the oops, it's turning one direction, now it's going the other direction, and now stops for a while, and then it's going to build up very slowly with that for loop, and that you can just see the pulses very gradually getting wider, and you can hear the motor going up to speed. There we've got the PWM pulses getting wider and the motor's getting faster. And as I said before, what's happening there is the DC component. That's if you know your Fourier series, or you don't really need Fourier series to work out the DC component, but it's part of the Fourier series, it's the DC component in there. The rest is getting filtered out by the motor. The motor acts like a filter to filter the higher harmonics out, although they obviously do have an effect on the motor. And you can see it's getting near maybe 80%, 90%. It's nearly at its maximum. With the motor. Nearly there. Pretty much nearly 100%, and it stopped. And that's the end of this demo.